The person got a motorbike which was 40,000 rand. After 5 years, the value was depreciated. So we use A equal to P times 1 minus I raised to the power of N. Our A is 26,700. Our P is 40,000. And we've got 1 minus the interest. Now the I, it will be R over 100. Okay? Then raised to the power of what? Of N. And our N is 5. So if you want to simplify this, you get 26,700 all over 40,000. This is equal to, there on the right, you can write that as, okay, I hope, what is R over 100? Right? So this one here, I can write it as, okay, if I simplify, in fact, I can write as 1 minus R over 100, okay, all raised to the power of 5. Okay? Then, since I need R, I can take the fifth root. Okay, my next step, I can take the fifth root of 26,700 all over 40,000. This is equal to 1 minus R over 100. Okay? Then, if I want my R, please allow me to just write the formula for R for me. My R will be equal to, it will be equal to, I can multiply the 1 by 100 and multiply the left hand side by 100. So if I do that, I'll get 100 minus 100 times the fifth root of 26,700 over 40,000. Okay? So if you simplify this, what you get. The good thing is I don't need to convert my answer to a percentage. It's going to come out as a percentage. Okay? But if you use the I, if you put I here or there, your final answer will be a decimal. Then you have to multiply that answer by 100. So, Tesha, can you just give me the answer?
7,766.
7, okay, to 2 decimal places.
7,77.
7.77%. Okay. So if you use the other method whereby you replace this I, so you replace the R over 100, or you just want to calculate the I first, you must get an answer which is 0.077. Then you multiply it by 100, you get your R. Okay? Please don't forget that there's a difference between the interest rate, and the rate as a percentage. Okay? All right. Then 7.2, a bank granted Nathan a loan of 1.2 million to buy a house. He agreed to repay the loan over a period of 15 years at an interest rate of 11.5% per annum compounded monthly. He made his first payment at the end of the first month after the loan was granted. Calculate Nathan's monthly installment. Right, this one is very straightforward. It's based on the basics of present value. So at T naught, 1.2 million rand is borrowed. The first payment is made at T1. Okay, there are 15 years, so 15 times 12. 15 times 12, that will give you, okay, 15 times 10 will give me 150 plus 30, so you get T180 here. Right? So if I want the monthly installment, because we have a loan here, it's a present value annuity, so it will be P equal to X times 1 minus 1 plus I raised to the power of minus n all over I. We want the monthly installment, so x will be equal to P, which is 1,200,000 times our I, that's 0,115 over 12. Okay, whatever amount we get here, we divide it by 1 minus 1 plus 0,115 over 12, all raised to the power of minus 180. So what answer do you get there?
14,018,28.
Right. So you get that amount. Okay, so it's a very straightforward question. Then 7.2.1. Now, due to some unforeseen circumstances, Nathan could not pay his 76, 77, 70, 80th, 70, 90th, and the 80th installments. So there were 5 payments that were skipped. Okay, he resumed his payment at the end of the 81st month. Calculate the outstanding balance at the end of the 80th month. Right, so it means that this question is saying he made 80 payments, then he skipped. Okay, so we need to know how much money was outstanding after the 80th payment. Okay, so we need to calculate the balance outstanding. So here, I'm just gonna use the first method. Okay, so our balance is equal to P times 1 plus I raised to the power of K. Okay, you can put N there, but as we did in class, we put K. So that would be 1 plus I raised to the power of N minus 1 all over I. We have got it from the previous question, right? 14,018, right? And 28 cents. So 14,018 and 28 cents. So that would be 1 plus 0,115 over 12. Okay. That's all raised to the power of 75 minus 1 all over 0,115 over 12. Remember, this is the balance outstanding after the 75th payment. Okay? So, what answer do you get?
925,435,58.
Okay. Now, this is not the balance outstanding. This is the balance, okay, before the delay. So I'll just call it before the delay. Or before the stoppage in what? In payments. Then amount, okay, total amount outstanding, total balance. I'll just call it total balance. Okay? This amount, which is the total balance now, it includes the interest that accumulates due to the stoppage in payments, which meant that there was a delay. Right? So, that amount we use compound interest, so it will be 925,435,58 times 1 plus 0,115 over 12, all raised to the power of 5. Because we skipped 5 months. Okay, so what answer do you get there as the total balance?
970,637,47.
Right, so you get that. So this is the amount that will be outstanding due to that stoppage in payments. Okay, so if the monthly installment does not change, since we know the balance outstanding, which means we are dealing with present value, so we write our formula P called X times 1 minus 1 plus I raised to the power of minus N all over I. Right? Our balance outstanding is now this one here, that's 9. This is our present value, 970. That's 970, 637, 637, comma 47. This will equal to the monthly payment, which is 14, which is 14018, comma 2, comma 28, right? Times 1 minus 1 plus 0.115 over 12, all raised to the power of minus n. Right? This is all over 0.115 over 12. Right? So Tasha, can you just do this calculation for me? Multiply this by that. Whatever answer you get, you divide it by that.
Sir, it's 0, comma 663 558 0414.
Okay, and then can you simplify this for me? So that will be 1 minus whatever is in that bracket. Can you just simplify it? Normally it's supposed to be a rational number.
2423 over 2400.
All that raised to the power of minus n. Then, if I take it to the right, 2423 over 2400, all raised to the power of minus n, right? Then subtract the 0.66 from 1. You get 0.3,
0.3364 419 586.
okay, so our n will be equal to the logarithm. I can put minus here, minus our base is 2423 over 2400 of 0.3364419,586. Okay, so what will be the n?
114,21.
114,21. Okay, now let's see what the question is asking. The question is saying, if he continues to pay the same monthly installment, how many months will it take him to pay the balance outstanding at the end of the 80th month? Right? So here, because we want the number of months, this, okay, remember that that 2 1, okay, because the number of payments and and the number of months for this question, they are more or less the same. So they are going to be 114 full payments. Okay, so it's 114 months plus a final month that the person has to pay off an amount which won't be equivalent to the monthly installment. So in my case, my answer here will be approximately 115. Okay. Any question? Is